Towers of Hanoi. Towers of Hanoi has historical roots in ceremony of ancient tower of Brahma. So, uh, towers of Hanoi were ancient. So this figure is of towers of Hanoi. There are n sticks of decreasing size mounted on one needle. There are n sticks of decreasing size mounted on one needle. Two more needles are also required to stack entire disc in decreasing order. Use of third needle is for impermanent storage. So needle C is like RAM. It is used for impermanent storage. So on first needle we have this discs. There are some rules for mounting discs. So these following rules should be followed. First, at a time only one disc can be moved. Second, disc may be moved from any needle to another needle. Third is no larger disc may be placed on smaller one. So these are three rules for moving. In this figure, our aim is to move discs from A to C using needle B as an intermediate. So in this figure A, needle A contains 5 discs and there are no discs on needle B and C. Arrow is indicating next operation to be performed. In this figure, which is figure B, needle A has only one disc. Needle C contains 4 discs. Arrow indicates the next operation, that is move 4 discs from C to B. So in needle A we have one disc. In needle B is empty and needle C has again some discs. So here we are moving from B to C. C to B. This is figure C. In figure C, needle B has 4 discs. Needle A has only one disc and it will be moved to C. So disc from A is moved to C, which is indicated by arrow. So this is figure C. This is figure D. In this figure, needle A is empty and needle C has only one disc, which is larger, and we can see that majority of discs are in B, which are arranged in descending order. So small disc is at top in on needle B, then there is a larger disc, then there is another larger disc. So arrow is shown which is pointing towards A, so this disc will go towards A now, or we will have to move towards A. So here again we have 3 needles. Needle A has discs which are arranged in a order such that larger disc is at top, then there is smaller, so in that way it has arranged. Now arrow is pointing towards B or C, so we will insert disc in third needle now. In this figure, needle A and B are empty and C is full because all discs are inserted in C now. So this was towers of Hanoi, and we have a program which is illustrating them. It is as follows. So this is a program which is illustrating the tower of Hanoi. So first two lines are basically for including library files. Include conio.hex and standard input output.hex. Now void Hanoi, this is a function. and we are defining int char. Now main function starts. Int num int num is for defining that num is an integer. Now clr this is for clear screen. Now printf /n this is for next line, enter a number. So we are telling user to enter a number. Now scanf %d ampersand num. So here we are taking input data. Again clr. Then hanoi number a c b. So we will go to hanoi function. Void hanoi int num char f peg char t peg char a peg. So this is hanoi function. If num is equal to 1, that is if num is true, then printf /n move disk 1 from needle %c to needle %c f peg t peg, then return hanoi num -1 f peg epg tpg. Printf n move disk %d from needle %c to needle %c. So let us check output of this program. So this is a C program. Now this is output of our program. First is move disk 1 from needle A to needle C, then move disk 2 from needle A to needle B, move disk 1 from needle C to needle B, move disk 3 from needle A to needle C, move disk A from B to A, move disk 2 from B to C, and move disk 1 from A to C.